Hey friends, so now we're gonna learn how to combine your data using 4 set operators: union, union all, except, and intersect. And we're gonna start with the basics like understanding the differences between them and the SQL joins. And we're gonna learn how they work, the syntax, and how SQL execute them behind the scenes. And after that, we're gonna learn the most important use cases for the set operators that I usually use in my projects. So now let's start with the first question: what are set operators? Okay, so what are SQL set operators? Set operators gonna go and combine the result of multiple queries into one single result set. So this definition sounds very similar to the SQL joins, right? There as well, we're gonna go and combine the result of multiple queries into one single result set. So what are the differences between joins and the set operators? Alright, so now let's say that we have two tables or two results from two different queries, the table A and the table B. And now you would like to go and combine those two different tables into one table, into one result. And here the question is, what do we want to combine? Do you want to combine the rows or do you want to combine the columns? So that means we have two different methods on how to combine data in SQL. So now let's say that we would like to combine the columns of table A and table B. Then we're gonna go and use the method of joining tables. So how SQL execute the joins? First, SQL gonna go to the table A and take the columns from there and put it at the results, and we call table A the left table. And then side by side, SQL gonna go and take the columns from table B and put it to the results, and we call table B here the right table. So as you can see in the output, we got columns from table A and we got columns from table B side by side in one wild table. So this is how SQL execute the joins. But now let's say that I would like to combine the rows from table A and table B, not combining the columns. And here we can go and use the method of set operators. So how SQL execute the set operator? It's gonna take first the columns from the first table, from the first query, so table A, and then beneath it, it's gonna go and append only the rows from table B. So as you can see, it's opposite at joins. We are not appending columns side by side, we are just appending the rows underneath each others. So in the output, we will get one long table. And this is exactly how the set operators works. It's gonna go and combine the rows from two tables. Now, of course, for those two methods, we have different types. As you know, in the joins, we have, for example, the inner join, the full join, left join, right join. And depend on the type, you're gonna go and combine the data differently. And as well for the set operators, we have different types. We have the union, union all, except, or sometimes we call it minus in different databases, and we have the intersect. So as you can see, they are really similar, right? And now we have as well a main requirement for each methods. For the joins, we have always to combine the data or join the tables using a key column. But with the set operators, we don't need a key column in order to combine the rows, we just have to have the same columns. So as you can see guys, joins and set operators are very similar. The main purpose is to combine different queries or different tables into one single result set. But the main differences here is the purpose. Do you want to combine the columns? Then go and use the joins. And if you want to combine the rows, then go and use the set operators. So my friends, this is why we have in SQL the set operators. Alright, so now let's have a look to the syntax of the set operators. Okay, so now let's see that we have the following query. We are selecting the data from the customers. So this is our first query or our first select statement. And we have another one which is very similar, where we are selecting the informations from the employees. And this is our second select statement. So now what we can do, we can put between those two queries a set operators, like for example the union. We can use, of course, any other set operators like the union all, intersects, excepts, and so on. So as you can see, the syntax is very simple. We have two different queries and we just put between them the set operator. So this is how the syntax of the set operators looks like. Alright friends, so now we're going to talk about the rules of the set operators, and we're going to start with the rule number 1, the SQL clauses. In each individual select statement or query, we can use almost all the SQL clauses like where, join, group by, having, but there is only one exception with the order by. Order by, you can use it only once and only at the end end of the entire query. So that means we cannot use order by in each select statement or in each query. We can use it only once and only at the end of the entire query. Alright, so about the syntax again, here we have our two select statements and in between them we have the set operators. So now in each query we can go and use multiple stuff like the join, where, group by, having, so we can make each query complex as we want. So everything is allowed but not the order by. The order by must be always placed at the end of the entire query. So if you want to sort the result by the first name, you have to use the order by exactly at the end. So we are not allowed to use order by in each query. Okay, moving on to the rule number 2, the number of columns. The number of columns in each query must be the same. Okay, so now in order to understand this rule, let's have this very simple example. We're gonna go and select the first name and the last name from the table sales customers. So this is our first query, our first select statement, and let's say that I have another one and we want to select the first name, last name, but this time from another table, the employees. So with that we have our two queries and I would like now to go and combine them into one result. So we're gonna go and use the set operator union. Let's go and execute it. So now as you can see in the result, we will get the first name and last name from two tables, the customers and employees. And it is working because we are fulfilling the rule where it says the number of columns must be the same in both queries. So how many columns do we have in the first query? We have 2, right? And as well in the second query, we have 2 columns. So that's why everything is working. So now let's go and break the rule by adding another column to the first query. So let's say that I would like to have the customer ID as well in the first query, and with that, as you can see, in the first query we have 3 columns, but in the second we have only 2. So let's go and execute it. Now as you can see in the result, we will get an error where it says if you are using union, intersect and all those set operators, you must have an equal number of columns between queries. So this is the rule. You have to have the same number of columns. In order to repair it, so I'm just gonna remove the customer ID. So here again we have 2 columns and the second one as well 2 columns, and everything gonna be working. Okay, moving on to the rule number 3, the data types of columns in each query must match, must be compatible in matching. In order to check that, what we're gonna do, we're gonna go to the Object Explorer to the left side. Let's go and browse the customers and the columns, and as you can see we have here the first name and last name with the same data type. We have the varchar, and if you go to the employees, you can see as well the first name, last name having varchar. So the first column is a varchar from the first query and as well for the employees, and as well the last name from the customers having the same data type as the last name from employees. So the data type is matching. Now let's go and break this rule. Instead of having the first name, I would like to go and use the customer ID. So now let's check the customer ID on the left side. It is an int, an integer, but the first name is in varchar. So here we have a mismatch between data types. Let's go and try to execute it. So now we are getting an error where it says SQL is trying to convert the value franc to an integer. So what this means? The first query is always controlling everything, the names and as well the data types. So here we have an integer, and now SQL is trying as well to convert the first name values to an integer, and of course it will not work because we have here characters inside and it cannot convert characters to an integer. So we have a mismatch between data types, between the customer ID and the first name, and that's why we will get an error. The second column we don't have an issue because it is varchar in the first table and as well for the second table. So now in order to repair it, either select a first name in the first query, or we can go over here and say employee ID, and with that, if I execute it, we will not get any errors because the employee ID is as well an integer and we have a match in the data types. So as you can see, it's not enough to have the same number of columns, you have to have as well matching data types between those two queries. Okay, let's move to the next rule, rule number 4, the order of columns. The order of columns in each query must be as well the same. Okay, so let's understand what this means. Now we have here again the same example where we are selecting the ID and last name from customers and we are combining it using union with the employee ID and last name from the employees. And as you can see, everything is working because we have the same number of columns and we have a matching data types. So now let's go and break it. What I'm gonna do, I'm just gonna switch between those two columns. So first I'm selecting the last name and then the customer ID. So again, I have the same number of columns and the ID is integer, matching the ID of the employee and the last name having the same data type. So let's go and execute it. So here again, SQL gonna throw an error and says SQL is trying to convert the value Goldberg to an integer. So it's like character to integer, it will not work. So what happened here? I have here the same informations. I have an ID and last name, an ID and last name. Well, SQL doesn't work like this. SQL gonna go and map the first column from the first query with the first column with the second query. So it's gonna go and map last name to employee ID. And since they have different data types, SQL gonna throw an error. So SQL doesn't understand or don't know how to map, let's say, the ID with the ID. And since they have different data types, SQL gonna go and throw an error. So as you can see here, we have the same informations between customers and employees, but they don't have the same order. So SQL cannot go and map the informations because of the names of the columns. It's gonna go and simply just mapping the columns like this. The first column from the first query with the first column from the second query. So as you can see in this rule, you must have the same order of the columns. First the ID and then the last name. And with that, it's gonna work again. Alright, moving on to the rule number 5, the column aliases. Column names that we see in the output in the result is defined and determined by the column names of the first query, the first select statements. So that means the first query is responsible of naming the columns in the output. Okay, so let's understand what this rule means. Again, we have the same example, the customer ID last name from customers, union, employee ID last name from employees. So if you check closely the output, you can see that in the output we have the customer ID and not the employee ID, even though we have the IDs from the employee ID. But as you can see, the first query is controlling the naming of the output. So since the first column called the customer ID, you will see it in the output as a customer ID. So the naming of the next queries will be totally ignored. So that's why if you want to give aliases to the output, you're gonna go and do it only for the first query. So for example, I go over here and say, instead of having customer ID, I would like to call it as an ID. So now if I go and execute it, as you can see in the output, we will get an ID. So I don't have to go and in each query give this alias. So I don't have to go over here and say, yeah, you are as well the ID, because it's enough to define it from the first query. So there is no need to give the same names in the next queries. Let's take another example where we would like to have an alias for the last name. So I would like to have it like this, last underscore name, and let's go and do it in the second query. So last underscore name, let's go and execute it. So now as you can see in the output, we still have last name and there is no underscore because this is totally ignored from SQL. This is not the first query. The first query says you are last name without underscore. So again, if you want to do that, we go over here. Let me just get it and put it in the first query. Let's go and execute it. So my friends, the first query is very important in order to give the names for the output. So if you want to do aliases and to rename stuff, do it only on the first query. And as well, the first query controls the data types. All right, now to the last rule, matching the correct informations. If in your query you fulfill all other rules and you don't have an error in the SQL, that doesn't mean that your result is accurate and correct. You are the only one that is responsible of mapping the informations between queries correctly, because SQL doesn't understand the content and the informations of your tables of your queries. And if you don't match the informations correctly between the queries, you will get inaccurate and wrong results in the output. Okay, so now back to our example. Let's say I would like to get the first name and as well the last name from the customers and the same informations from the employees. Let's go and execute it. Now as you can see, it's very nice where we are getting the first name, last name from both tables in one result. And we are fulfilling all the requirements in SQL, same numbers, same data types, and so on. Now let's go and make incorrect results. So what I'm gonna do, I'm just gonna swap the first name and last name in the second query. So first, last name, and then the first name. So let's go and execute it. So now as you can see, we will get results because we are fulfilling all other rules, because we have the same number of columns and as well we have matching data types. So the first one is character, the first name, and the last name is as well character. So SQL will just present the result as you define it. But the result is completely wrong, because now we have, if you check the first column here, the first name, so here we can see last names inside the first names. For example, Brown and Baker, those are last names, but we can see them inside the first name. And the same thing in the last name, now we can see first names inside it. Mary, Carol, they are all first names. So as you can see, the result has really bad data quality. We are now mixing stuff and it doesn't make any sense. But SQL will not know that, because SQL doesn't know the information, the content of your data. It's just mapping the data types. So first name is varchar, the last name as well varchar, everything is fine, and you will get the results. So my friends, you are responsible of having the same informations mapped between the two queries, and not having an error from SQL doesn't mean that we have now correct results. So pay attention to the informations that you are mapping between the two queries. Alright, so those are the rules of the set operators. So the first one is that the order by can only be used once at the end of the entire query, and all queries must have the same number of columns, the matching data types, the same order of columns, and the first query always control the names and the aliases of the result set and as well the data type. And the last rule is that make sure that you are mapping the correct informations to each other's between queries. So those are the rules of the set operators. Okay, so what is union? Union gonna go and return all distinct unique rows from both queries. So that means it's gonna go and combine everything, and all the rows gonna be presented at the output. So since it says all distinct unique rows, that means union gonna go and remove all duplicates from the combined result sets. So union gonna make sure that each row gonna appear only once. Alright, so now let's have this very simple example. We have two sets of data. We have the customers, where we have 5 customers with the first names, and as well we have another set called employees, and we have as well the first names of the employees, and we have 5 employees. And now if you take a look to the first names, you can see that we have the same persons as the customers and as well as employees. We have Kevin and Mary in both sets of data. So now how is SQL gonna execute union? It's gonna go and return everyone from customers and everyone from the employees. But now since we have Kevin and Mary twice, in the output we're gonna have them only once. So this is how the union works. It's gonna go and return everyone from 2 sets but without duplicates. Alright, so now we have the following task, and it says combine the data from employees and customers into one table. So that means in one table we want to combine all informations from employees and customers. So which informations do we need? This is the first question that I usually ask myself. So in order to do that, first we have to explore the data. So select star from sales customers and then semicolon. Then I'm gonna write another query. Select star from sales and employees and semicolon. So now why I'm using 2 different semicolons? Because I'm telling SQL we have now 2 separate queries. They have nothing to do with each other's. And if you go and execute it like this, and now in the output you can see we got 2 result grids. The first result grid is for the first query and the second one for the second query. So they have nothing to do with each other's. I just want to explore those 2 tables in order to understand how I'm gonna map those informations. So now if we check those 2 tables, you can see that both of them has IDs. So we can map those informations, right? Both of them has as well first name, last name. So that means I can go and map the first name and last name together. Now in the customers we have country, but we don't have this information in the employee, so we have to go and ignore it. And we have as well here score, where we don't have a score for the employees. That means I can go and map 3 informations between the customers and employees. Now of course we can go and think, do we need really the IDs? Because it doesn't make really any sense to have the IDs in the tables. It's not any more unique because we have here the customer ID 1 and employee 1. So I think we can go and ignore it. So the only really 2 information that is useful to map is the first name and last name. So now let's go and add those 2 informations. So we need the first name, last name, and the same informations as well from the employees, but now we want everything to be in one query. That's why I'm gonna go and remove the semicolons, and now we have to go and use set operators between those 2 queries. And now in order to combine the data, we have 2 options, either union or union all. In this example, it doesn't mention anything about duplicates and so on. I would like to go with the union in order to remove the duplicates if there is any. So that's it. Let's go and execute it. Now, as you can see in the output, we have only one result because we have only one big query. And now we have the first names and last names from the customers and employees. And now one more thing about the order of the queries. It doesn't matter whether we start with the employees or with the customers, we will get the exact same results, but pay attention to the naming of the columns. Always the first query controls the names, but since now they have the same naming, so it should not be a problem. So if I go and switch those two tables and start it again, we will get exact same results. So now let's understand how SQL did combine the data using the union. Okay, so now we have here the results from the first query and the second query, employees and customers, and we are combining the data using union. The first step in SQL is that it's gonna go and take the columns from the first query, which is from the employees. So it's gonna take the first name, last name as a column name to the results. And now the next step is that SQL gonna go and start combining the rows between those two tables. So first it's gonna go and take the rows from employees, and as well it's gonna check whether there is duplicates in the data. So as you can see, we don't have here any duplicates, so we're gonna have the 5 employees. And now the next step is gonna start adding rows from the second query from the customers very carefully without generating any duplicates. We don't have it in the output, that's why SQL gonna go and add it to the result, append it. And then the next customer, we have Kevin Brown. As you can see, we have it already in the results. That's why SQL will not go and add it to the result, otherwise it's gonna go and generate duplicates. So SQL gonna ignore this customer. The same thing for Mary. We have Mary as well in the results, so it's gonna skip it. And then we're gonna go to the Mark. As you can see, we don't have Mark in the results. That's why SQL gonna go and take this customer and put it in the output. And then the last one, we have Anna. We don't have Anna in the results. That's why SQL can go and as well add it to the results. And now with this, SQL did combine the rows between those two tables, and we have here 8 persons. So as you can see, SQL is combining the data, but very carefully, not generating any duplicates. Alright, so that's it. This is how the union operator works. Okay, so now union all. Union all gonna go and return all rows from both queries. So it's very similar to union. It's gonna go and combine all the rows and everything gonna be presented in the combined result set. But the big difference to the union all will not remove any duplicates. It is the only set operators that doesn't remove duplicates, and it's gonna show all the rows as it is. So if you have a row 10 times from the query, you will find it as well in the output 10 times. Now you might ask me when to use union and when to use union all. I'm gonna say that there is one big difference between them, is that union all has way better performance and it's faster than the union. And that's because union all doesn't perform additional steps like removing duplicates. So my friends, that means if you know already that in my queries there is no duplicates, I know my tables, I know my queries, there is no duplicates, don't use union and always use union all because you will get better performance. Another scenario for the union all is that I would like to see the duplicate. I'm doing data quality checks and I would like to see whether there is duplicates after I combine multiple queries. So in this situation, I go and use as well the union all. Now we have again the same example. We have the customers and employees, and we have as well the same persons, Kevin and Mary, as customers and as well as employees. So now if you want to combine the data using union all, it's gonna return all rows including duplicates. So that means SQL gonna go and execute union all like this. It's gonna return everything from customers and everything from employees, and Kevin and Mary gonna be presented twice in the output. So as you can see, union all is returning all the rows as it is from the two result sets. And if there is duplicates in the sets, we will get as well duplicates in the output. So Kevin gonna be existing twice in the output and Mary as well twice. So this is how the union all works. Alright, so now we have very similar SQL task, and it says combine the data from employees and customers into one table including duplicates. So it's exactly like the last task, but this time in the task we are saying include duplicates. So we cannot go and use union, we have now to go and use union all. We will have the exact same query, so we are selecting the employees first last name and as well customers first last name. And now instead of using union, we're gonna go and use union all. So all what we have to do is that to go over here and say union all. So now pay attention to this. As you can see in the union previously, we got 8 records or 8 persons customers from the output. So now let's go and execute it and check the results. Now as you can see, we got now 10 persons instead of 8, and that's because we have 5 customers and 5 employees, and we have duplicates inside the data. We have 2 duplicates. Now if you check, we have here Mary, and as well over here we have Mary, and same goes for Kevin. We have Kevin over here and as well here. So we have duplicates inside the data, and SQL just combined the 2 tables. Okay, so now we can understand how SQL execute union all in order to combine data. Alright, again we have the 2 results from queries. We have the employees and customers, and SQL gonna do the same steps. First, gonna go and get the column names from the first query and put it in the output. SQL gonna go and take all the employees and put it in the output without checking anything. So that means if there is duplicates in the data, it's going to be presented as well in the output. It's very simple. Now SQL going to go to the second step and as well take all the customers and append it into the output like this. So that's it. It's very fast. It's going to go and just combine all the rows from the employees and all the rows from the customers, and with that we're going to get the 10 persons. And as you can see, we have duplicates in the data, so we have Mary twice and Kevin as well twice. And that's why union all is the fastest. It doesn't have any extra steps or checks, just taking all rows from all queries and put it in the output. Alright, so as you can see, it's very simple, right? So that's all for the union all. Okay, so what is except? Sometimes we call it minus in other databases, but in SQL Server we call it except. So it's gonna go and return a distinct rows from the first query that are not found in the second query. So from this definition we can understand that the order of the queries can affect the final result. There is a first query and a second query. So it is the only set operator where you have to pay attention to the order of the queries. And as well, it's like the others, it's gonna go and remove the duplicates from the result set. Alright, again we have this very simple example. We have 2 sets, 5 customers, 5 employees, and there is the same persons as a customer and as employees, Kevin and Mary. So now we're gonna go and combine those 2 sets using the except, or sometimes we call it minus. So it says it's gonna return unique rows in the first table that are not in the second table. So what can happen? What is the first table? Let's say the customers on the left side. So here we have 5 persons: Joseph, Mark, Anna, Kevin and Mary. So now the rule is we need the customers that are not employees. So it's safe for Joseph, Mark and Anna because they are not existing in the second set. That's why SQL gonna return those 3 values. But now for the 2 customers, Kevin and Mary, here there is an issue. Kevin and Mary, they are members of the second set, the second table, the employees. That's why SQL gonna go and exclude them from the output because they are not fulfilling the rule. So the output will get only 3 customers, and all the values from employees and the common values between customers and employees will be excluded from the output. So this is how the except works. Alright, so let's have a very simple SQL task, and it says find the employees who are not customers at the same time. Okay, so let's see how we're gonna solve that. We're gonna stay with the same queries as usual. We have the employees and the customers, but instead of having union all, we're gonna use the set operator except. So now since we are using except, we have to make sure that the order of the queries are correct. So the first query is the employees, which is correct because we have to find the employees who are not customers at the same time. So we are focusing on the employees. The first table is correct and the second table is customers. If the task says find the customers who are not employees at the same time, then we have to go and switch it. We have first to query the customers. So now everything is correct. Let's go and execute it. And now in the output, we see 3 employees who are not customers at the same time. So we have Carol, Frank, and Michael. But as we know, we have 5 employees, Kevin and Mary. They are not here in the result because they are customers as well. So now let me show you what can happen if I just switch those informations. So we start with customers and then with employees. Let's go and execute it. As you can see, we're gonna get completely different results. Now we are getting customers informations. And now in the output, we got 3 customers who are not employees at the same time. This is not what you want from this task. So if you do it like this, it's gonna be incorrect. So pay always attention here to the order of the query. So now let's go and correct it. So we're gonna have first employees and then customers. Let's execute it. And now let's go and understand how SQL execute the except operator. Alright, so again, we have the results from the 2 queries or from 2 tables. And now we are doing except between them. So let's see how SQL gonna execute execute it, it's going to take, as usual, first the names from the first query from the employees and put it in the output. And now SQL going to present data only from the first query in the output, and it's going to go and use the customers only as a check. So SQL will not put any data or rows from the customers. It will just use the second query as a lookup in order to check the data. So it's going to start with the first employee, Frank Lee. Do we have Frank Lee in the customers? Well, no, we don't have it. That's why SQL going to accept it and put it in the output. And then in the next step, SQL going to go to the second employee and check. As you can see, we have it already in the customers. So SQL going to go and ignore it. It's not allowed to be in the output. The same thing for Mary, we have it as well in the customers, that's why it will not be presented in the output. So Michael, we don't have a Michael in customers, that's why it can be presented in the output. And as well for Carol, the same thing, we don't have Carol as a customer, and we're gonna have it in the output. So as you can see, we will get data only from the first table, and the second table only going to be used in order to check the information from it. So we don't have in the output any customers, it's only employees. So now let's check quickly what's going to happen if we switch the tables. So now we have the customers as the first table. SQL going to take the columns from the first table and it's going to start presenting the customers' informations in the output, and it's going to go and use the employees only as a lookup. So do we have Joseph? We don't have it in the employee. And then Kevin and Mary, we have it already in the employees, and Mark and Anna are not part of the employees. That's why SQL can go and present the results in the output like this. So now as you can see, SQL is focusing on the table customers, and we are getting data from the customers, not from the employees. Employees is only as a check. So with that, we understand the order of the queries is very important for the exceptions. We will get different results if we have different order. Alright, so that's all for the except operator. Okay, so what is intersect? Intersect gonna go and return only rows that are common in both queries. It's something very similar to the inner join, and as well here it's gonna go and remove duplicates, so there will be no duplicates in the output. Alright, again we have this very simple example where we have 5 customers and 5 employees, and now we're gonna combine them using the intersect. So what intersect does, it's gonna go and return common rows between 2 tables. So how is SQL gonna execute it? It's very simple. SQL gonna go and search for the common values. So what are the common values? It's Kevin and Mary, and SQL gonna return only those 2 values, Kevin and Mary, and all others gonna be excluded from the results. So it's very simple, right? It's gonna go and return only the common values, and this is how the intersect works in SQL. Okay, let's have this simple task, and it says find the employees who are also customers. So we're gonna have the same queries, employees and customers, but instead of having except, we're gonna go and use intersect, since we are finding the common informations between the employees and customers. It's very simple and straightforward. Let's go and execute it, and with that we're gonna get the Kevin and Mary. This is the 2 persons that are at the same time employees and customers. And of course here we don't have to pay attention to the order of the queries. It's gonna be the same if we say find the customers who are also employees. So if you go and just switch, for example, the customers with employees, you will see that we will get the exact same results. So it doesn't matter which query is first. Again, pay attention to the first query that define the names. So now let's understand how SQL execute intersects behind the scenes. Okay, again, our 2 tables, and now we are doing intersects. So as usual, SQL gonna go and take the columns from the first query, and now we're gonna go and find the common data between those 2 results. So it's gonna do it row by row. So we have the employee Frank. Do we have it as a customer? No. So it will not be in the output. Kevin Brown, we have it in the employees and as well as a customer over here. So that's why we will get it in the output. The same thing for Mary. So we have Mary as employee and as well as customer. So we can have it in the output. Michael and Carol, they are not customers, they are only employees. That's why we will not get it in the output. The same thing goes for the customers. Joseph, we don't have Mark, we don't have Anna because they are not employees. So with that, we're going to get only the common informations between the 2 tables or 2 queries. And it doesn't matter whether we start with customer or with employees, we will get at the end the same information. Alright, so that's all. It's very simple, right? This is how the intersect works in SQL. Alright friends, so now we come to the part where I'm going to show you how I usually use the set operators in my projects for data analysis or for data engineering. So here are the most important use cases for the set operators. Alright, the first use case is combining similar tables before doing data analysis. In some scenarios, we want to generate a report and we end up writing similar queries on top of similar tables, and we go at the end and join all the results from the queries in order to present the final report. And now instead of doing that, what we can do, first we can go and combine all the similar informations into one table, and then we can do on top of it a query, a data analysis in order to generate a report. And we can do that using the union or union all. Let's have a few examples. So let's say that we have 4 tables: employees, customers, suppliers, and students. So as you can see, all of them are sharing the same informations. They hold data about persons. So now let's say that you are generating a report that requires all the individuals in the organization in the database. So what you're going to end up doing is writing a SQL query for the employees, another one for customers, and as well for the suppliers and the students. And then you're gonna go and merge all the results from those queries into the final report. Now the issue with this setup is that you are having a lot of queries, a lot of similar queries, so you have it here 4 times. And now what might happen is that you go and change the logic of the first 2 queries and you forget later to do it for the other 2, and you will get really inconsistent data in the reports. So instead of that, what we can do, we can go and use the set operators in order to combine first all those tables in one big table. So what we're gonna do, we're gonna go and use a union in order to combine those 4 tables into the table persons. So we're gonna have it like this. So we will get all the rows from the employees and put it in the persons, all the rows from the customers, from the suppliers, and as well from the students, and put everything in one big table that holds all the informations about the individuals that we have inside our database. And now the next step after we combine the data, now we write an SQL query in order to analyze this new big table, and the result gonna be presented in the reports. And now of course the advantage here is that we have only one SQL query for the data analysis on top of this table instead of having it 4 times. And now if you go and change the logic of the SQL query, it's going to be applied automatically on all the data that we have in the database. And we have done already this example where we have combined the data between the employees and customers. Another scenario where we have to combine data before doing any reporting is that sometimes the database developers tend to divide a table, one big table, into multiple small tables in order to optimize the performance. For example here, splitting the orders by the year. We have orders 2022, 2023. Now again here, if you want to generate a report in order to analyze the orders over the years, over the time, either you're going to go and make a query for each of those tables, or you're going to go first combining all those tables into one table called orders. So what we're going to do, we're going to use a union between all those tables in order to generate one central table called the orders. So all the rows from the first table and all rows from the next table, the next one, and the last one. So we're gonna put everything in one big table, and once we have the orders, we're gonna go and write analytical SQL query on top of the orders in order to generate the report. So as you can see, it's a very important step in order to prepare the data before doing data analysis. Okay, so now let's have the following SQL task, and it says the orders are stored in separate tables. We have the orders and orders archive. Now combine all orders data into one report without duplicates. Okay, so by looking to the task, we have to combine 2 tables, orders and orders archive, so either union or union all, but since the task says without duplicates, that means we have to go with the union. But now before we combine any data, we have first to understand the content of the orders and the orders archive in order to map the columns correctly. So first we have to go and explore the 2 tables. So let's start with selecting the data from orders, everything, semicolon, and as well from the second table, sales, orders, archive, and as well semicolon. So let's go and execute it. So now in the output we get 2 results because we have 2 separate queries. The first result is for the orders and the second one is for the orders archive. Let me just make it a little bit bigger. And now as you can see, we have almost identical tables. So as you can see, we have the order ID, product ID, customer ID. So everything looks like identical. And of course we can go and check that using the Object Explorer on the left side. So we have here the orders and those are the columns. And if you go to the orders archive, you can see that we have the exact same columns. So that means we can go and map all columns from orders with all columns of orders archive. So let's go and do that. So I'm just going to remove all semicolons, and then we're going to go and use the union. So now we have everything in one query. Let's go and execute it. Now we will get in the output one single result, one single table with all informations from orders and orders archive. So we have all orders now in one table, and everything currently is matching. So with that, we have solved the task. We have one result with all orders. We don't have any duplicates since we are using union, and we have combined the data. But now we have one issue with that. This solution, this query is quick and dirty, and actually it's not following the best practices. So now the best practices here is to list clearly all the columns in each query without using star. Alright, so now let's go and do that. Now we need a list of all columns from the table orders and the table orders archive. And since we have a lot of columns, what we're gonna do, we go to Object Explorer, right click on the table name, and then let's go select the top 1000 rows. So let's click on that, and now we're gonna get a very simple select statements where we have all the column names from the table orders. This is what I usually do if I need all the columns in my select statements. So let's go and copy it and go back to our query. Then let's go replace the first star with those columns, and we're gonna do the same thing as well for the orders archive since they have the same names. So let's go and do that as well. So let me just make this smaller in order to see the query. So now we have a select for the table orders with all columns, and as well a select with all columns for the table orders archive. So let's go and execute it. And of course, now we're going to go and get the same results. Now you might ask why we are doing this. Why didn't we stick with the star? It's quick, it's simple. Well, for the following reason. So now currently the status is that everything is matching. We have 100% identical tables. But what happened with the time is that we do development in our solution and we might go and change the schema of the table orders. So we might rename stuff, we might add new columns, or maybe switch the columns. So this means the table order with the time will not be anymore identical with the archive. And this is of course a problem if you are mapping the data blindly using the star. So now let me show you what I mean. Let's say that in this table, we are developing the orders and we just switch those two columns in the schema for some reason. So now we have the product ID first and then the order ID. So let's go and execute it. Now, if you are using star, you will not notice these informations. But if you are using script, you're gonna see immediately that here we have first the order ID and then product ID, and here we have the opposite. So it's more clear listing the columns than using the star. And now, as you can see in the output, you're gonna see that we have a problem that here we have order IDs, and then suddenly we have something like the product ID. So we're gonna have incorrect data, which leads to incorrect analysis. So here the best practice is to not use the star and to clearly list all the columns. Now, one more technique that I usually use once I'm combining data is that I add the source of the data inside the query. So what I mean with that, now you can see that we have here two orders with the order ID 1. They are not duplicates, they are completely different informations, and that's because they come from different tables. So what I usually do, I go and add the source of each record. It's really nice information for the analytics, for the users to understand where these records come from. So how are we gonna do that? We're gonna have, for example, on the first column, the following word, let's say orders, and we're gonna call it, let's say that's source table, and we're gonna do the same thing as well in the second query, right? So the source table here is not the orders, it's the orders archive. So I'm just adding static columns to my query in order to see the source of the table. So now we have here two different values, and let's go and execute it. And now you see we have created a new column called source table where it has only two values. We have the orders and the orders archive. Let's go and sort the data by the order ID. So order by order ID. So let's go and execute it. And now you can see it very clearly. The first order, order ID 1, comes from the table orders, and the second one comes from the orders archive. So this is really nice information that you can add to your data once you are combining multiple tables. So that's all about this use case on how to combine data between different tables. Alright, now we have another use case for the set operators. It's more for data engineers. We can use the except in order to find the delta between two batches of data. For example, data engineers build data pipelines in order to load daily new data from the source systems to a data warehouse or a data lake. Now, in those data pipelines, we have to build a logic in order to identify what are the new data that is generated from the source system in order to insert it in the data warehouse. One way to do it is to use the set operator except in order to compare the current data with the previous load. Let's have a very simple example. In the day number 1, we have two customers, 1 and 2. So what's gonna happen in this day? We're gonna go and load those two customers into the data warehouse. So in the data warehouse, we will get as well 1 and 2. So this is for the first day, nothing is crazy, we just load the data as it is. Now for the second day, we will get new data from the source system and it's gonna look like this. So now if you check the second day, you can see that we have again the customer number 1. We have already loaded to the data warehouse. So we have it as the previous day, but we have a new customer ID number 3. So now in order to load only the new data, we don't need to load again the customer number 1. What we can do an except between the day number 2 with the previous load with the day number 1. So now if we simply do an except between those two sets, we're gonna go and identify the new data that is existing in the source system, which is only the record number 3. So now what's gonna happen if we do except between day 2 and day 1, we will get one record, the new record that we're gonna go and insert it inside our data warehouse. So as you can see, this set operator except is very powerful in order to compare two sets, and not only for data analysis, we can use it, as you can see, for data engineering in order to identify what is the new data that is generated from the sources in order to insert it inside our data warehouse. Okay, one more use case for the set operators that I personally use a lot in my project is that if you are doing data migrations, you can use the except in order to check the data quality, and more specifically, we can use it in order to check the data completeness. Okay, so we have the following scenario where we are doing data migrations between two databases. So let's say that we would like to move this table from database A to database B. So we're gonna go and load the table to the new database. And now what is very important after you move the data is that to check whether all the records did move from database A to database B, we are not missing anything, even one record. So we want to do data completeness test, and there are many methods on how to do this test. One of them is to use that set operator except. So how are we gonna do it? We're gonna do an except between the table from database A and the table from database B in order to find any record that is still in database A which is not migrated to the database B. And of course, the best result is that we will not get anything. The result should be empty. If we get an empty, that means all the rows from database A exists in the database B. And now, of course, we are not done yet. We want to do the comparison, but the way around. We want to find any new rows that is in database B that we don't find in database A. Those two tables must be identical. So now what we're gonna do? We're gonna do an except, but the first table gonna be from the database B, and then we're gonna compare it with the database A. And we have the same expectation. The output should be as well empty. And now after doing the except twice for both sides, and we are getting empty in the results, that means those two tables are identical and we are not missing anything. So this is another amazing use case for the set operators in order to improve the quality of your data migrations and in order to do data completeness tests. Okay, so now let's have a quick summary about the set operators. So the set operator is going to go and combine the rows of multiple queries, multiple tables into one single result. And we have 4 different types of the set operators. The first one is the union, where it's going to go and combine all the rows, but without including any duplicates. The second one, we have the union all. It's very similar. And the third one, we have the except. It's going to show all the rows from the first query that cannot be found in the second query. And the fourth one, we have the intersect, where it's going to show the common rows between two queries. And of course, we have SQL rules in order to use the set operators. Both of the queries should have the same number of columns, the same data types, and the order of columns. And the last rule, don't forget that the first query controls the aliases, the name of the columns and the data types of the entire result. And we have found amazing use cases for the set operators, like for example using union and union all in order to combine similar informations into one big table, or we can go and use the amazing except operator in order to compare two different results in order to find the differences between them, and I usually use it in order to do data quality checks to test the data completeness. And another use case, as a data engineer, you can go and implement the except in your logic in your data pipelines in order to identify what are the new data that must be inserted in your system. Alright, so with that we have learned how to combine your data using the set operators. They are amazing in order to reshape the data for analysis. And now in the next chapter we're going to focus on the case statements. It is a very powerful tool in order to create logical conditions and as well to generate and derive new informations. If you like this video and you want me to create more content like this, I'm gonna really appreciate it if you support the channel by subscribing, liking, sharing, commenting. All those stuff gonna help the channel with the YouTube algorithm, and as well my content gonna reach the others. So thank you so much for watching, and I will see you in the next tutorial. Bye.